Hello everyone, welcome back to my YouTube channel. I am Maunika from Sri Venkateshwara College of Engineering from the Department of Basic Science, Program Computer Science and Engineering, subject Applied Physics. Today we are going to discuss about how to create animated character using physics. Physics in animation. One of the trends in visual media is an ever increasing demand for realism and graphic fidelity. This is most visible in live action works and for a good reason. Live action media is realistic by default. So, when visual effects are used in a live action work, these effects too have to be realistic just so they won't look out of place. Nowadays, physics is used everywhere in computer graphics. One of the best example is so-called physics-based rendering, an advanced method of visualizing image that takes into account the flow of light as well as reflectivity and other characteristics of surfaces in the image. Scene lighting also benefits greatly from using physically accurate approaches, as we have demonstrated at the beginning of the article. Even post processing effects such as lens flares or depth of the field are nothing more than an attempt to imitate real world phenomena. In addition to image rendering, physics is widely used to make things move. The most simple and perhaps oldest example of this would be basic rigid body simulation. We have basic geometric shapes to which some basic laws of physics, primarily gravity and friction, are applied. Scenes like these were first introduced in pre-rendered works like commercial, movies, and TV shows. However, this kind of physical simulation does not require overly complex calculations, so as the technology advanced, they started to appear in real-time application as well and are still widely used. A similar but more advanced example would be fluid dynamics. Here, a large number of physical bodies are used to approximate the movement of body of water. Physics and characters. Historically, the first attempt to combine character animation and physics was so called ragdoll physics. The idea here is similar to simply rigid body physics we have already seen. Several geometrical shapes are linked together to roughly approximate the character's body. Simulation is then run for these bodies to calculate how the character would move in free fall. The resulting motion is then transferred to a character. Just like regular physics simulation, Ragdoll can be used in both pre-rendered and real-time sequences with equal ease. Ragdoll can provide some impressive results, and at the time it was considered a major achievement in combining physics with animation. Even today, while not as omnipresent as before, it is still widely used. But what is more important, it was this technique that led to another more advanced solution. Now, let us know how physics is applied in animation. Firstly, kinematics and motion. In animation, understanding kinematics is fundamental. Kinematics deals with motion of objects without considering the force that caused the motion. Animators use concepts such as position, velocity, and acceleration to create realistic movements. Example, when animating a character walking, the animator considers the character's stride length, speed, and how different parts of the body move in sync with the motion. This involves applying kinematic equation to ensure a natural and believable walking animation. Second, Newton's law of motion. Newton's laws are backbone of classic mechanics and are extensively used in animation to depict realistic motion. First law, law of inertia. An object at rest stays at rest, and an object in motion stays in motion unless acted upon by a net external force. Example, when animating a car coming to a stop, the animator considers how braking force gradually slows down the car, adhering to the first law. Newton's second law: the force acting on an object is equal to mass of that object multiplied by its acceleration. Example, in a scene where a character throws a ball, the animator calculates the force applied based on the mass of the ball and desired acceleration. Newton's third law: for every action, there is an equal and opposite reaction. Example, when a character jumps off the ground, the animator considers the reaction force pushing the character upward, providing a realistic lift of motion. Third, projectile motion. Projectile motion is a key concept in physics and is frequently applied in animation, especially when dealing with a throwing or launching objects. Example, if animating a character throwing a baseball, the animator considers the angle, initial velocity, and gravity's effect to depict the accurate trajectory of the baseball. Fourth, fluid dynamics. Fluid dynamics principles are employed when animating liquid, gases, and other fluid-like substances. Example, an animator simulating a pouring liquid like water from a bottle uses fluid dynamics to portray the realistic behavior of the liquid as it flows and interacts with the surroundings. The images of projectile motion and fluid dynamics. Fifth, gravity. Animators apply the principle of gravity to create realistic movements. Objects fall at an acceleration due to gravity, and animators simulate this effect by adjusting the speed and timing of falling objects. This ensures that characters and objects move as they would in the real world. Sixth, collision and impact. Physics guides that animation of collisions and impacts between the objects. Animators must consider how objects deform upon impact and how forces are transferred and how motion changes as a result of collision. This attention to detail enhances the visual realism of the animation. As you can see, the images of gravity and collision. Seventh, rigging and character animation. Physics is applied in rigging, the process of creating a digital skeleton for the characters. Joint movements and deformation follows anatomical principles to make character animation look natural. Animators also use physics-based simulation for hair, clothing, and other dynamic elements attached to characters. 8. Particle system. Animators use particle system to simulate a large number of small objects like raindrops, snowflakes, or sparks. Physics-based rules govern the behavior of these particles, allowing animators to create realistic effects like rain showers or explosions. As you can see the images of rigging particle system. In conclusion, the integration of physics in animation enhances the quality and authenticity means real of animated content. By adhering to the laws of physics, animators create a more impressive experience for viewers, making characters and scenes feel natural and believable. The careful application of physics principles adds depth and realism to animated worlds, elevating the overall quality of the animation. Thank you. Don't forget to like, share, and subscribe my YouTube channel.